All right, yesterday we did the ISN for 11.1 and we started this packet. So we were up to number 5. We had actually discussed the formulas and did number 1, 2, 3, 4, and we're going to pick up here on 5. We'll watch it. The tile floor. The tile floor of a bathroom is made of black and white parallelograms. Each parallelogram is made of 2 triangles with the dimensions as shown. Find the perimeter and area of the parallelogram. All right, so what is this value? Yeah, that would just be the 11, guys. That would be the base. The height is the 6.7. It's drawn on the exterior because this is tilted. So that is 6.7 for the height. The area of a parallelogram, I'll do first because that's really quick to do here. We've got base times height for the area. The base is 11, the height is 6.7. So 11 times 6.7 would give us our area. This is old stuff. So I'll clear that. 11 times 6.7. And then we need to label it correctly. It's 73.7. And those are in centimeters. So we write centimeters squared, I know is how you guys say it, which is really square centimeters. And now we want to find the perimeter. This top is the same as the bottom because the opposite sides in a parallelogram are congruent. So if that was 11, your base, then this would be 11 as well. Okay, now let's carefully decide what number is actually on the side here. Is matching with there, so that would be 7. Oops. Okay, when that happens, go get a pen. This is 7, and so the opposite sides again are congruent, so that would be 7. So now if you want the perimeter of the parallelogram, those are the numbers we add up. So we got 7 plus 7 plus 11 plus 11. 22 and 14. 36 centimeters around. Okay. Yeah, because that's that piece right there. So the 6.7 is the tallness of the parallelogram. It is not the length of a side. Okay. For whatever reason, we have another number 6. I'm sorry, I pulled up something I already went over in first hour. So I'm going to get rid of this stuff quick. Just say number 6 on it for you. Okay, we corrected that apparently. You do not have this picture, so you might want to make yourself a parallelogram. It says that the height of the parallelogram is 5 feet more than its base. So that would mean that the base is smaller. Yes, it is slanted, not a rectangle. You don't have to make it just like mine. I mean, say it's all right if you want to make it bigger or smaller. I just made one so I could kind of give you an idea of what that might look like. If the base is smaller, I'm going to let it be X. I'm going to put an X on the base down here. The height of the figure comes, I like to draw them from a vertex. It really can be anywhere between the bases and perpendicular between them. I usually like to come from a corner, but you don't have to. Bless you. Any line drawn from the top side to the base down here at the bottom, which is matching, top and bottom, make it perpendicular, and that would be your height. Now, the height is 5 feet more than the base. Does more mean to add or multiply? Yeah, it does. It means to add. Plus 5. All right, so if the base is x, then the height would be x plus 5. The area formula for the parallelogram is base times height. Now I'm going to plug in those values I put in, and I'm going to plug in the fact that it says that the area of the parallelogram is 66 square feet. That would be the A value. So I'm putting in 66 for the A. I'm using x for my base times, and I'm going to put that in parentheses, x plus 5 for my height. On the right, we would need to distribute to solve. So I'm going to multiply x times x and x times 5, which would give me 66 equals x squared plus 5 times x. Now back in Algebra 1, you may remember solving some equations that had 3 terms and there was a 0 on one side. I am going to subtract 66 from both sides and set this left side to 0. This is going to equal x squared plus 5x minus 66. You would have not done any problems like this year. I will not be putting it on the test, but I want to expose you to it for Algebra 2 next year, because you will be solving problems that have these kind of equations. If you set this to 0, you can do something called factoring. So I'm going to write this over here just to give me some space over these blanks. So 0 equals x squared plus 5x minus 66. Maybe you recall doing something called diamonds or unfoiling and foiling. Remember something like that? Yeah, well, we're going to figure out 2 binomials that multiply to give you this trinomial. We're going to put an x here and an x here. Now we want to take the number 66, and you guys, can you tell me some numbers that multiply to give you 66? Okay, 11 times 6 is definitely 66. 1 times 66 is 66. Yes, 30. 3 times 2, there's several of them. But just think about this. I want a pair of multipliers that will add to 5. Remember something about diamonds with that? I don't know if you remember factoring or not, but I need the pair of numbers that multiply to give us 66 that also add to 5. Okay, so if you wanted to add to 5, you would be using the 11 and the 6, because if you made the 11 positive and the 6 negative, you would get a sum of 5. So we put a plus 11 in and a minus 6. Again, I'm not going to be testing you on factoring because we would have to do a lot of practice on factoring again before we would do that. But what you do then is you take each of these factors of that trinomial and you set them to 0. Well, I don't have to put parentheses around it, but if I subtracted 11, then I'd have x equals negative 11. And if I set the other one to 0 and solve it, I get x equals positive 6. Now, which answer makes sense in this problem since it's a length? The 6. The 11, negative 11 can't be the length of a side. So that's the one we choose, and then you eliminate the extraneous solution. So x equals 6 was the base. So our base is 6 feet. And our height would be, we would plug 6 in here and get 6 plus 5, which is 11 feet. My pen's stuck. Right, it looks like an eraser. Okay, and again, I want to expose you to that problem. Find the perimeter and area of each triangle. Round to the nearest tenth if necessary. Okay, well, if I want to find the area, then I'm going to need to know this height right here. If I need to know that height, I'm going to have to use this given information that's not part of the triangle we're finding the area and perimeter of. The shaded one is the triangle that we're finding the area and perimeter of. So I'm going to need to know the base, which is right here, B, and I need to know its height, because area is base times height divided by 2. So the first step is going to be for us to find the height, and we're going to use Pythagorean theorem. The height here is a leg, the 3 is a leg, and the 5 is the hypotenuse. And we know that the Pythagorean theorem says that leg squared plus leg squared, if I could get this thing, sorry, it's acting up. Leg squared plus leg squared equals hypotenuse squared. So I've got 8 squared plus 3 squared equals 5 squared. 8 squared plus 9 equals 25. We're going to subtract 9 from both sides to get 16, and then take the square root. So how big is h? Yep, 4. Thank you. All right, so if the height's 4, we can do the area of this triangle now. Area is base times height. We're going to substitute in B is 15 times the height we just found, which is 4. Divide that by 2. So you want to multiply this first. Careful how you type, but you can just do 15 times 4 divided by 2. This one's okay if you type it all at once. Okay, that's 30. And then we properly label it with square centimeters. The perimeter, now we have another triangle we've got to deal with. If we want to do the perimeter, we're going to need to know this side. So this is the triangle I'm looking at. It's also a right triangle. And we got to find the hypotenuse on it. I'm just going to call this x, because I already used some other letter. X is fine. That's the hypotenuse, so x squared equals 15 squared plus 4 squared. X squared is going to equal 225 plus 16. Adding that gives us 241. So we'll need to take the square root of 241. So you guys, I know, just do most of this work on your calculator. Okay. Thanks, Amato. 15.5. You are right. Okay, so I'll put that on here. All right, now I'm going to be able to find the perimeter. So I'm just going to add up all the sides. What numbers are we going to add? 15.5 plus 15, and then what else? The 4. So that should be 34.5, and that be in centimeters. That Pythagorean theorem just doesn't go away. Got to use it a lot. There's a lot of applications for it. No. Monday. I think that should be fine. Okay, I didn't get a chance to erase these. Looks like there's a little work going on there, huh? Yeah. What? I got it. I'm just erasing because I had done these first hour and I forgot I didn't save this hour yesterday. All right. A few more to go, and then we're going to do the ISN notes for 11.2. All right. We have some extra information on one of these diagrams. Number 8. I have 11 right here. What does the 11 represent on that gray triangle? So the height's 11. What is the 40? Okay, that would be the base. Right, writing in highlighters always messes with me. All right, so those are all we need for doing the area of a triangle, because the area of a triangle formula is base times height divided by 2. When it's not a triangle, okay? So the only time we're dividing by 2 yet, well, but we have another formula that's going to have a half in it, so we're doing that one today. I'll talk to you about it in a bit. All right, so let's go ahead and get that area out of the way. Our base is 40 times 11 divided by 2 is 220. And then we need a label of square inches, or inches squared, like you think it. Next, we're going to have to do Pythagorean theorem to find this hypotenuse. I'm going to put an x on it. And the hypotenuse, x squared, would equal the legs squared and added. 11 squared plus 40 squared, and then we'll have to take the square root. So we just grab the calculator and start typing. 11 squared plus 40 squared. Take the square root of the result. Oops. And then hit enter. All right, we've got 41 point, let's go 41.5. Okay. Okay, can you remind me, I took the square root of 17, was it 40? 21? Thank you. All right, so our perimeter, what numbers we need? Notice that the 15 was extra information. We really didn't need it. 11 plus 40 plus 41.5 would give us our perimeter. So 92.5, and it was in inches. Yep, not bad. Just inches, because it's perimeter. All right, now on number 9, what students usually do incorrectly on this is not notice where the base is. The base is the 13. What's the height? All right, 9. Okay, so we've got the height and we've got the base. So we can do our area right away. Let's get that out of the way before we worry about the perimeter. The area of the triangle is base 13 times the height 9 divided by 2. And if you calculated that, you probably got, you can hit that all at once. Yes, Nathan, 58.5. And the label on that is square centimeters. The next part, though, sometimes we have trouble with this idea. What kind of triangle is that if it has isosceles and you need to find the hypotenuse? Remember the 45, 45, 90? You could do Pythagorean theorem and get that, or you could do the special right triangles. Now, I've got those on the walls. If the n root 2, n root 2, n root 2 would be 9 times the square root of 2. That's a lot faster than even bothering to calculate with the Pythagorean theorem, if you know the pattern. So I'm going to leave it 9 root 2 for a minute. The problem is I want the perimeter of the gray part only. So now I need to find this, and I'm going to label it with an X. How am I going to get it? The gray triangle is not a right triangle. So I am going to still need to do Pythagorean theorem, but it's going to be for a much bigger triangle. Check this out. Why? What kind of triangle is this ginormous one? There's a right triangle, right? This X is the hypotenuse of the big old right triangles. This one's got a little bit more challenge to it. What we would need to do is say, well, what's the base of that big triangle? 13 plus 9. So this would be 22 for that side. This bright triangle that I'm working with right now, highlighted in the bright green, is a base of 22, a height of 9, and we want to find its hypotenuse. So this would be x squared equals 22 squared plus 9 squared. So I'm going to find out what that length is. 22 squared plus 9 squared. Okay, and then we're going to take the square root of the 565. Oh, I did type something wrong. That is not an L5 problem, whatever that came. Second square root. I hit the wrong button. Good. Yeah, well, how are we going to round this if we just want to go to the 10th? 23.8. All right, that's this side right here, 23.8. We were taking the square root of 565. Yep. Now, and I wrote everything down. You probably wouldn't write this much down. You might do more of it on the calculator. So if that's 23.8, the perimeter of the big, all right, just the gray one now, is the 23.8 plus 13 at the bottom there, and then this right here, which is 9 times the square root of 2. Now, I'm not going to write that in my answer. I'm just going to type it on the calculator now. I'll do my 23.8 plus 9 plus, oh no, it wasn't 9, it was 13, right? And then I got to add on the 9 root 2. I guess I could have done it in a different order, would have been fine. I don't know how I got all that junky in there. I'm having trouble with my typing here. Right, just stop thinking about food then, Nathan. Apparently. 49.5. And you still probably got the same answer, right? Is it, did you have a little off on the decimal only? Okay, well, let's see what happened. If you did Pythagorean theorem, instead of special right triangles, you did 9 squared plus 9 squared. And then you should have taken the square root of that. Right? If you wrote 12.7 here, it's still should work out to the same answer. So if you did that 23.8 plus 13 plus 12.7, you probably added in the 22. Okay. So I don't care if you had 12.7 or 2 root 9, 2, it doesn't matter. I mean 9 root 2. When you type it out, you should get 49.5. Oh yeah, and that's just in centimeters. All right, our last example for, oh wait, 2 more. 10, find the perimeter and area of each figure. For finding the area, we're all set because 18 would be the height and the base would be 26. 26 times 18 divided by 2 is our area. And thank you, you guys are faster than I can get this up here. 234 square inches for our area. All right, now we're missing one piece for the perimeter, and it happens to be the hypotenuse. So let's find of that gray triangle because it's a right triangle as well. X squared equals 18 squared plus 26 squared. Or doesn't really matter what order. Square root of 1,000. Can you please stop? 31.6. All right, so add up those gray sides, 18 and 26, and the 31.6. All right, thank you. 75.6 inches. Next one's a little bit more challenging. It says the base of a triangle is 1/2 of its height. I'd rather not have a half in my problem, wouldn't you? Because, I don't know, y'all don't seem to love fractions a whole lot. So let's just discuss which is smaller. If the base of a triangle is half the height, then the base is smaller. All right, it's half as much. So I'll let the base equal x. All right, so I'm going to let the base be x. Then the height, since it's twice as big, the height of that would be, the base is half the height. So I'd have to make 2x for the height because half of 2x would give me the x. All right. Now, it says the area A is 36. I'm going to write down the formula, and I suggest you do that when you do these problems. Area of a triangle is base times height divided by 2. What I have decided is I've got an area of 36. I'm going to put that in for A. I made the base be x, and I made the height 2x. So 2x, or x times 2x divided by 2 would be in the formula. By properties of fractions, if you have a product in the numerator and you have something in the denominator, you can reduce. So why don't we just cancel out the 2 since we're dividing by 2 here. Now we have 36 equals x times x is x squared. So you take the square root of 36 to get x, which would be 6. So if 6 is x, then the base is 6 millimeters because it was in square millimeters for the area. And the height is 2 times 6, so it'd be 12 millimeters. Okay, you need to work on this tonight. This is what you're going to be assigned, is to work on the practice. Be prepared with questions for tomorrow on it. I'm going to start though right now the 11-2 ISN. So we're going to look at a few more formulas today. In your ISN, 11.2 starts with the area of a trapezoid, rhombus, and kite. Okay, I'd like to show you where the trapezoid formula comes from. You do not need to write this down, but let me kind of just demonstrate for you where it came from. If you had a nice big parallelogram, we've already learned that its base times height is its formula for its area. Okay? But if I took this shape, this parallelogram, and I cut it into 2, no, I don't. You do not need to draw this. I'm just doing an illustration. I want you to see where a formula came from. It just helps you understand why the formula is what it is. Not that I'm going to test you on that. I just want to show you. I just cut that parallelogram into 2 equivalent or congruent trapezoids. See it? One's going, it looks like one of these things. Right? That and that. The parallelogram had a height right there. Now it looks even more like it. Okay? what I did was take this base and I cut it into two pieces. So I'm going to need to label this maybe base 1, and I'm going to call that would be the same as right up here, base 1. And if I called this base 2, this would be the same as it, so it'd be a B2 also. For this to fit in the formula, and this being the height, the area of this big parallelogram would now be B1 plus B2. And then you would multiply that times the height to get the area of that entire thing. Agreed? Okay, now, how much of this do we want if we only want to do one trapezoid? So to do one trapezoid, we only want, this is the area of the entire thing. We only want one of them, so we would have to cut that area in half. So that's why the formula for just that one is half of base 1 plus base 2 times the height. That would give me the area of just one of those. That's where this got developed from. Okay, so when you're doing a trapezoid, you're going to need to take bases and add them. Basically, you're averaging the bases. I'm going to use this one where we do adding the bases first and then divide by 2. And then we're going to multiply by the height. Okay, that's how we're going to work it. Now, talking about rhombi and kites. We're going to use this one. Area is a diagonal times a diagonal divided by 2. I could explain where those came from. Pretty much, let's just think about the fact that there's 4 congruent triangles in there, right? All 4 of them the same size. Each of them, you would do base times height divided by 2. But there's 2 of them, so it cancels out the 1/2. So you just do diagonal times diagonal divided by 2 because there's a total of 4 of them. So you just cut your, okay, you see how this is a base and that's a height? That's the same base and that's the height going that way. You don't want to divide by 2 twice. That's why you only do it once. Because you're putting them together. 2 sets of triangles. All right, so all you need to remember is diagonal times diagonal. Notice the diagonals are often drawn on the exterior because it's hard to draw them on here and show what the numbers are. It's the same for a kite. Diagonal times diagonal divided by 2. All right, let's try some problems. We've got the first one's a trapezoid. Okay, the formulas are, you have them written down next to your picture, right? For example 1. Okay, I'm going to use this one. All right, the area of this one, what might help is for you to decide what's what. This is base 1, this would be base 2, and this would be the height. So let's pop them in the formula. We've got a 40 plus 18 for adding the bases. We're going to divide that sum by 2, and then we're going to multiply by 15. 40 plus 18 is 58. 58 divided by 2 is 29. Then we do 29 times 15. I'm following the order of operations that need to be done in order to get the accurate result. Well, let me show you something. What were we adding first? The 40 plus the 18? Okay, now you cannot do this. The height was 15, right? Okay, this is wrong. Why is it wrong? Very good, Mono. It's going to go by order of operations, which would tell it to divide before and then multiply and then add. So we would need to put the parentheses in. If you want to type it all at once, you're going to have to do it like this, and then you can hit the times 15. Now, I had 29 times 15 when I broke it down. I'll double check. These match. All right, so careful, do not type it like this. 435 is the answer. And that would be labeled with square meters. Yes? Oh, pardon me. Okay, now everybody has an ISN. Area of the trapezoid. Now this trapezoid just happens to be slid sideways, so I don't really care which one you call base 1 and which one you call base 2. I'm going to do it this way, and then I'm going to just get started. The area for number 2, add 12 and 24, cut it in half after you add it, and then multiply by the height, 28. Okay, so I just went ahead and went down to what 18 times 28. You can type it all at once if you wish. But you're going to have to type in those parentheses. As long as you're getting 504, we're good. Right, so basically, you're just popping in numbers into these formulas. These are the easy kind because it's all given. Did I go too fast on that one? Okay, 11.2, continue, area of the rhombus and the kite. Find the area of the rhombus. It's diagonal. I'm going to do diagonal times diagonal divided by 2. I don't have to type in a fraction. One diagonal is 7. The other would be going that way, and it's drawn out here, and it's 9. You can see that that comes to the tips of that, like that. That's what it's showing. So to do the area for this one, we're just going to do 7 times 9 divided by 2, which is 63 divided by 2, and that's going to be, what, 31.5. It's in square meters here, but I see on the figure it's labeled in centimeters, so that's not right. This should say square centimeters. We are not going to convert it to meters. Okay, make it much smaller. All right, find the area of each rhombus or kite. What do you think 4 is? A kite or a rhombus? Sure is, because the diagonals aren't congruent. All right, one diagonal is 20 plus 20. So I'm going to write down diagonal 1 is 40. And diagonal 2 is the other one, 56 plus 26, which would be 82. Right, so now I'll do the formula. Area is diagonal times diagonal. So 40 times 82, but don't forget to divide by 2. What is that? What? Gotta be bigger than that. 1,640? Oh, yeah, no. Multiply the diagonals and divide by 2. No, that's glad we caught that then. My, you've been very talkative today. Okay, let's check out this diagonal. You see the slash marks? The diagonals are bisected. So that means it's a parallelogram. 10, 10. That'd be 20 for D1. And then going the other way, how big is it? Double slash marks means both of these are 20, so D2 is 40. All right, the area for this one is 20 times 40 divided by 2. What shape does this one have to be? Diagonals are perpendicular and they bisect each other. So that is a, gosh, we want to remember. We got to remember these properties back for finals. This one would have to be a rhombus. It would be 400 square centimeters. I'm not sure how this is working out, but I'm trying to replace well, part of the video. Working backwards problem. It says one diagonal of a kite is 3 times as long as the other diagonal. So we're going to let the first diagonal, or D1, equal x. Then the other diagonal, D2, would be 3 times as long, so it would be 3 times x. It says if the area is 294 square inches, then we know A is 294. Since the formula for area of a kite is diagonal 1 times diagonal 2 divided by 2, I'm going to replace the A with the 294, the D1 with an x, and the D2 with 3 times x. And then, of course, divided by 2 is a part of the formula. In order to solve this one, I'm going to multiply both sides by 2 to get the division of 2 out of there. 2 times 294 is 588. And the 2's cancel out on the right. That's why we did that. X times 3x is 3x squared, which next would have us solving for x squared. We would divide by 3 on both sides. 588 divided by 3 is 196, and that equals x squared. So now final step, take the square root of 196 to get that value of x, which would be 14. One of the diagonals is 14, and that would be in inches because the area was square inches. The other diagonal would be 3 times 14, which is 30 plus 12, 42 inches. We have one more problem to fill out in our ISN, and it's involving a trapezoid. I am just going to start writing down everything it says we have. The height is 6 inches, so h equals 6. One of the bases is 15, so I'll let it be B1. And the area, which we use A for, A is 120. The formula for the area of trapezoid, I'm just going to copy down, is B1 plus B2. The base is added, divided by 2, and then multiply by the height. Filling that in with what we have been given, the 120 goes in for the A, the 15 for the B1. I don't know B2, and that was like my question. What is the length of the other base? B2 is the question. So I'll have to leave B2 in the formula. That's supposed to be over 2. And then multiply that by 6 for h. Okay, to solve this problem, there's multiple ways that we can get this algebraically solved. One way would be, well, just multiply both sides by 2 here to get that division out of there. So we'd have 240 equals, and then I'd still have the 15 plus B2, and that would be in parentheses still, then times the 6. Now, you could have divided the 2 into the 6, but I chose to get rid of the division first. All right, now we're going to need to get rid of 6, and since this is a product, I am going to divide now by 6 on both sides. It's going to give me 40 is equal to 15 plus B2. I really don't need the parentheses any longer. So I can now just subtract 15 from both sides, which gives us 40 minus 15 is 25. So B2 is 25 inches. Okay, we will continue tomorrow with the packet on 11.2 and do some more examples for you. Have a great day.